Hello everybody, welcome to today's classic seminar. It's my pleasure to introduce Jim Curlander, Principal Program Manager of augmented reality at Microsoft. Jim has over 25 years of experience working in computer vision. He earned his bachelor and master degrees from here at University of Colorado in electrical engineering and optoelectronics computing. He spent more than 15 years in the remote sensing field, and then he joined Microsoft to lead the development and scale out of 3D cityscapes for virtual Earth. And he's now the principal program manager for augmented reality. So, welcome.
Thank you. Thanks. So, thanks for that great introduction. It's so disturbing when I hear 25 years. It just seems like a lot. But yeah, thanks. Wait till it's 45. That's good. All right, I hope I don't have to, but okay. So let me tell you a little bit more about program management at Microsoft and what I do, first of all, before I dive into augmented reality. So I'm a program manager. So I'm a leader of program managers in an organization for augmented reality. Microsoft is a matrixed, it's a siloed, matrixed architecture when it comes to the organization. So I work with a development manager who manages development leads and a test manager who manages test leads. And then that group together across makes a feature team. So augmented reality is a feature team that consists of 4 program managers, about 40 developers, and some number of testers. Okay? And then, but I report up to a program management manager, something like that, director, and they report on up, and finally it gets to a vice president or something like that, and that's where it comes together. But it's interesting because the team that I work with, the developers, don't report to me. They report to somebody else. They report to a development manager. So I can't tell them what to do. I can only influence them, try to make them see what I see, the things that I think should be done. And so my job is primarily the job of the program manager at Microsoft is primarily to come up with the what and the why. And the why is really important. The what is obvious, right? What is it that we're going to do here? And why is, and the reason I have to come up with the why really well is because the developers have to believe me that the why makes any sense. Because if they don't believe me, they're just going to not do what I suggest. They're just going to do what they want to do because they don't have to do what I say. And I also have to explain the why up to my management team so that they know what I'm doing and why that's important and why they're going to all be proud of me because I'm going to make them look great. And I have to explain the why out to my peer teams, other teams that are doing things that aren't augmented reality, because they're going to want to know why I'm using so much resources. And they aren't getting the resources that I'm getting, and I have to explain why that makes sense. So that's what I do. And a lot of what I do is, besides all the why and explaining things to a lot of people, is I watch the trends in the industry, and I see where things are going, and I pay attention to what people are doing, and the way social is changing, and the way the web is changing, and what people are doing with apps, and where the trends are going, and where the technological trends are going, and that helps me decide what we ought to do next. So what kinds of things we should do. And then through that is I try to set the strategy for the team, and then I tell the dev teams what we ought to be doing, and they tell me it's impossible, and we go from there, basically. So that's kind of me. So what is augmented reality? I'm sure you guys are all wondering, what is augmented reality? So augmented reality is seeing things that aren't really there, right? So this, you're looking at something and there's something not really there, and it's kind of this strange thing that you see. So when I was in school here, when I was in school here, we had augmented reality. You guys probably didn't know. So it was a long time ago. It was deep in the last century. We had augmented reality, but it was a lot slower. In fact, sometimes it would take 3 or 4 of us, like a whole weekend of concentrated effort with the right materials, and then eventually we would see things that weren't there. But this is the old way, and so now there's a newer approach now because we have technology, right? So there's this concept of seeing things that aren't like in a space, but you can see through a phone. And the thing is about this is kind of weird, these little soldiers and the Superman and that sort of thing that you see on this slide. Not particularly useful, right? But the concept of augmented reality is to take the things that we see on the web and the things that we do on the web and all that structured content that's out there and bring it into your reality in a way that's useful to you. And you don't even have to think about just the phone. This is very visual. People always think of augmented reality as visual, but we have 5 senses, right? We have our ability to touch, ability to see, ability to hear, and smell and taste. We're not doing much with smell and taste right now, but we're doing all 3 of the others, touching and hearing and seeing. And thinking about as you receive those sensory inputs, augmenting those things in a way that makes sense and brings in all that information from the web to the user, to the consumer, in a really compelling, really exciting way that makes it fun to use and fun to have and interesting. That's kind of what we're trying to do. Okay? Did I say everything? I think so. Oh, yeah, right. What I'm going to do in the presentation. So what I'm going to talk about in the presentation, I'm going to go through scenarios first. So scenarios is kind of what a program manager does. We think about, and a lot of the way Microsoft works is called scenario-based engineering. So we think about how a user is going to use something. What are they going to do? How are they going to use it? What makes sense? And we really detail that out in as much depth as we can do. And then we come back and say, well, how are we going to do this? How do we actually make this happen? What's the engineering behind it? What are the tasks? What are the features that have to be there? How do we build those features? What are the tasks? And then the things that are impossible, we put off till later, things like that. And so I'm going to talk about the scenarios. Then I'm going to go back and see the same scenarios, and I'm going to pick them apart and talk to you about the technology that's in there, and what's the status of that technology, where we are, what's really reasonable of the things that we see, and what's unreasonable and what's impossible. And then I'm going to talk about the challenges and what's near and in the near term and what's in the long term and where we think that the industry is going. Okay? So, this is another example of augmented reality, right? I meant to say that. So you can use the phone, or you can walk around with this kind of thing on your head. There's a lot of this, people walking around with this claptrap on their head, but that's a little bit weird. Anyway, I'll go to the next one. So this is Microsoft's vision. Hopefully this video is going to work. This is Microsoft Office Vision. It's a video, and it has a lot of neat ideas in it that really think about useful, valuable, time-saving things. And I'm going to let you guys watch this. I hope it just works. Come on. Oh, good. Is there any way to make it louder? Can you guys even hear it? Yeah, it's not good. The music is really good. Let's try that again. I completely love these little cards. So what I want to know is if they had that car made for this video, or but anyway, so this is one sort of vision, some interesting stuff in there, which I'll point out later when we get back to it, but I don't know if you guys noticed, at the beginning, unfortunately, it was so quiet, but she puts on these glasses and she touches them and it says translating. And the guy is talking, and he's saying like, step to the curb to get your taxi or something like that. He's speaking a different language. And then she turns it on and he's speaking the same language. She can understand him. So that's one of the things. And there's some cool stuff in there, but I'll break down into that when we get into the next part. So that's Microsoft's vision, and I don't know what year that's supposed to be. But now there's this guy. I don't know who that guy is. Some dude. He's got that thing on his head. Looks kind of funny. But that's the Google. You guys recognize him maybe? So Google just recently announced these glasses, and they released a video associated with that, which I thought was actually a really good video, and I'm going to show it. I'm not even going to show the one that's the parody on it. I was really tempted to do that, but I won't. I'm going to show you this one, and I'm going to show you this one from the Minority Report, which has also got some really great augmented reality stuff in it. So you can sort of get some ideas of the kinds of things that are out there. Let's see if this will pop up in front. Oh, puts it over there. And that's good, but there's, you can see it. Google has better sound than me. Oh, no. The sound is great, though.
Yeah.
Oh, come on. What's going on with that?
Maybe in front of Strand Books at 2.
Well, maybe it's on a different. All right, let's just try this again.
Really?
Yeah, really, I agree. Oh, man. Really? All right. I'm just going to not full screen it because it's. It must be Seattle, it's cloudy.
Yeah. Maybe in front of Strand Books at 2. Oh man, really? Sweet. Remind me to buy tickets for Monsieur Gano tonight. Where's the music section? Oh, yeah. This is it. Is Paul here yet? Hey, dude. How's it going? Sure. Hey, just a second. Cool. Thanks, man. See you, dude. Whoa, cool. Take a photo of this. Share it to my circles. Oh, I'm running late. Music, stop.
Hi, what's up?
Hey,
Hey.
you want to say something cool?
Yeah, sure. Let's go in.
Yep. Okay.
Isn't that sweet? What a good guy. Yeah, those are great glasses. Pretty cool, huh? So let me see if I can do this other one here. Do you guys remember the movie Minority Report? I don't know when it came out, 2000 or something like that. So this is a scene from the mall. I mean, it was a really interesting version of the of sort of augmented reality stuff. It's really quiet again. Well, maybe I know what's going on. Maybe it's this thing. Is it this? Aha! Let's try that again. It's a little better. So if you guys remember this, the ads are scanning him and they're calling him by name. That's kind of the idea there. Anyway, the thing I love, you know, if you saw that at the end, he's walking along, you know, and there's all this really super spectacular stuff, and it's all talking, and then he looks over and there's this webcam, and it's like freaking this big. You see that? I always thought that was hilarious. Part of the. Let me go back now. Yeah, right. So that humongous webcam, and what it always reminded me of was. Like in Star Trek, you know, they always had, you guys probably don't remember Star Trek, maybe for me, the original Star Trek way back in the 60s, you know, they had all this great technology and then, you know, like they'd have this, I hate it when that happens, pardon me. There, they'd have all this great technology and then they'd have the tricorder, right? It's great technology, but look, it's got a little cathode ray tube on it. I thought that was hilarious. It's got, you know, it's super technology. They can beam people to the planet, but then they have a CRT on the tricorder. So that's what happens with science fiction. You never know. But it's, you know, it's like Star Trek. There's lots of great technology things in there that we can mine. The same thing with that Minority Report one. So we'll come back and look at that too in a minute. Let me see if this is going to take me to the next screen. Oh, good. So this is another scenario. This is along with the sort of scenario-based engineering that we do. This is, you guys probably recognize this piece, Dolly piece. But imagine you're in a museum. You're walking through a museum and you'd like to know more about the art in the museum. So this is actually a very close to home, easy to build kind of thing. I'll come back to that. But you know, you could hold up your device, phone, or your super duper Google glasses, or maybe Microsoft will have glasses someday, I don't know, or your tablet. And it would be able to recognize the art. It's seen the art many times, and it would recognize it. It would reco it against a big database of art, and then pull out all the information associated with it, and then you could have that information displayed right there. So you could sort of have all this information, sort of like the Wikipedia concept, and you could see about the artist and who he was, and then maybe there's even links in there that take you to other things and that sort of thing. So that's kind of a artistic image reco kind of thing. So that's one kind of idea. Here's another one. This, I don't know if there's any mechanics in the room. This is a very simple looking engine, actually. I could probably work on this engine, even me. I can see the spark plugs and everything. But my new car, I won't tell you what it is, but when you open the hood, it's this big, smooth, titanium looking thing. You can't see anything in there. I don't know how even to open it. I don't even want to touch it, which is fine. So somebody else does that now, but that's fine. You can't, I don't know where the plugs are. I don't even know where to put the oil in or anything. It's completely impossible, and I don't know how to even figure it out. So you could imagine an augmented reality kind of application that goes on your laptop or your tablet that you could hold up, and it would say, here's where the plugs are, go here, take out the screws, and you could go around the engine and look at it in 3D and figure out what to do, and it could give you a step-by-step instruction kind of thing. So, basically. This is another concept for heads-up display. Same kind of thing. This is really a heads-up display concept. You could have the same kind of thing in a city. If you have demographic information and you can recognize the building, you can use the tablet to then figure out heads-up information about that. By the way, if anybody has questions, just feel free to interrupt me. That's fine.
That last one
Yeah.
exists, right?
Which? This?
Yeah. There's some iPhone and apps that, it says the restaurant that's 2 blocks away.
There are apps that do that, but they don't tell you what the building is. So this is an interesting one because, and like I said, I'll talk about the technology. I'm trying to scenario first, but I'll tell you, the apps that do that based on your on the GPS location of the phone and on the IMU position of the phone, attitude, position, and attitude. But they don't know what you're looking at. And the problem is if that data is not accurate, and I don't know if you've played with any of these apps, but what you'll find is that they'll point you, they'll say the restaurant is there and it's actually over here. But it's close, and the further away you get, the worse it is. So this is obviously science fiction here, but see this line? It's outlining the building. I mean, I suppose it could do that with image processing. But to know where that is and how to place that on the display, you have to reco the building in order to do that. Yeah?
So, first question, do we need to carry a device? Why not just embedding everything in the environment, like example? I want to do something that's available on the days.
I'm not following.
Sorry. So in order
Yes.
So can we free keep a device? We can embed everything in the environment. For example, here I want to be shorting. I just make clean the face.
You mean if the desk was a device, like the Surface?
Yeah, airblade embedded device.
Sure. I mean, that's great. We could do that.
Yeah.
It's science fiction for the device on the table and the wall, but it's a good idea.
Yeah, the other question is that, for example, I'm on my office, right?
Mm-hmm.
But I want to listen to your lecture, but I don't want to come here. Is that possible? So,
I think it's being videotaped, so that solves that for you.
just like I'm sitting here, giving you a feeling that I'm sitting here.
Oh, so you're talking about telepresence. So the concept of, I'll repeat your question because it's on the video. I believe what you're saying is, go ahead.
We can have a virtual reality embedded around me, right? So I'm sitting in my office, I say I want to listen to your talk.
Mm-hmm.
Give me a feeling, the reality that I'm sitting here.
Mm-hmm.
Did I ask?
That's telepresence. So you're sitting in your office at home and you want to make it feel like you're sitting here.
Yeah, that's right.
So I am being telepresent to you,
Yeah.
right? You're not telepresent to me because your chair is empty, right? We could make your chair full and put a hologram of you there too. Yeah, so that's augmented reality. That's related to augmented reality. But in order to do that, you have to have some kind of display device.
Okay.
You have to be able to see this surrounding. You know, something like a pair of glasses that you have on that has displays in them would give you a completely augmented surround. That's a possibility. I suppose you could sit in the middle of a whole bunch of TVs. That's a possibility, right? But there has to be a way to display the data to you. You have to be able to.
A three-dimensional picture, not just a screen. Have this, different sense, right? The touch and the see here.
I'm again not quite.
There are caves for augmented reality.
Yes.
Where you you have the screens and they project in 3D, and with the glasses you actually reproduce the 3D things, and with special gloves, and it's being done that you will use. I guess that's what you're asking. I mean, but I don't know if you do that. Or like, for the scenarios, maybe it's not right now.
Yeah, I mean, I think there's a way to do that. You just have to have the device. So it's about the environment that you absorb the experience through, right? But the telepresence is actually not trivial either. That's actually really hard problem. But let me charge ahead and we'll come back to this. I went to the next slide. Okay, so this one, here's my living room. It's actually not my living room. It's a pretty cool living room. I wouldn't mind having it. But imagine you're out in the world and you're looking at, and you see a car that's really cool. And you'd like to check out that car, but you don't have time to go down to the dealership and, spend time with the dealer and all the hassle that they give you and all that. And you don't want to sort of hover around the car. It's somebody else's car, right? So you're kind of looking at it, right? You don't want to do that. So you can maybe take a picture of the car, or maybe you take a picture of the nameplate on it or something else. And then when you get home, you could reproduce that car in your living room. And then you could go and walk around it with your device and experience this thing in 3D. And it could even be animated, right? You could open the hood and look inside it. You could get inside and look at the cockpit of it. You could have it, you could figure out what the sound of the engine was when it's running. You could watch the wheels turn, things like that. All of that stuff could be enabled. And then you could have as much time as you want with it and walk around with it and see it. This is kind of another sort of augments that space, and you can look at the thing in your own room. Here's another one that's, okay, so this is ads. This is near and dear to Google, for sure. Yeah, how to do ads with augmented reality. There's a few scenarios here. The one on the upper right is pretty cool. It's basically, it applies image recognition to catalog. So there's the catalog up there with all the cute models and everything, and then as you hold your device over it, it allows you to see the models in different poses, and maybe even with different clothes on, and maybe even different kinds of models, and maybe they have models that look more like the rest of us. So you can see what the clothes look like, right? Or things like that. And then you can actually, you can click there and see different things. So it's kind of an idea with that. This one down here in the lower right-hand corner is a kid. It's hard to see it, but it looks like an iPad or something. And the kid is looking through the iPad at a book, and the characters are popping out of the book. So they're these interactive characters in the book. So instead of just reading, now you can actually watch a 3D thing. And it's 3D, and it's using the book as a, I'm not supposed to talk about the technology yet, but it's using the book as a planar target. So as you move around, you can sort of look around it and see the thing from all different angles. And then this one over here is more like a classic planar target. It's basically an animation or a rendering that's popping out of a 2D target here. And you can render all sorts of things like this in 3D. So that could be like an ad. You could imagine walking down the street and seeing an ad of, I don't know, from Starbucks, something sticking out or something like that. Or you look off in the distance at the Ford dealership and there's this big thing floating around in the air or something like that. That's the kind of thing that you can get from a 2D planar target. And then this is augmented TV. This is a couple of apps that exist. This one's called Viggle. It's out of New York City. And this one is called VideoSurf, which is a company that Microsoft just acquired. Both of them provide a companion app for TV. What they do is they recognize the TV by the video or by the audio of the sound on the TV. They have feeds on the back end that are live broadcast. And then you get a second screen experience with your TV. So, like for example, I was watching, don't laugh, I was watching Dancing with the Stars the other night with my 4-year-old daughter. So that's why I'm watching Dancing with the Stars. And I was thinking, how old is Gladys Knight? So Gladys Knight is on Dancing with the Stars. And I'm like, how old is she anyway? She's got to be like 70 or something. So I pulled out my phone and I looked it up on there, and it turns out that she's like 67. And she did her first gig when she was 13, and that was in like 50 something. And then she was with Motown. And so I read all about her, instead of watching Dancing with the Stars, I was reading all about Gladys Knight. So now I'm a lot smarter about Gladys Knight. But anyway, that's the kind of thing you can do with a second screen experience. You can figure out who the actresses are, who the actors are, what their age is, anything else you want to know, like, that Tom Cruise thing we saw earlier. I don't know how old he was in that picture. It'd be kind of interesting to know that. And then there's also things like chatter, like what's going on Twitter about this show. I don't know if you guys ever connect to Twitter when you're watching TV. If you look at the hashtag for the show, there's usually all kinds of stuff. People are talking to each other about the show while the show is on. Facebook, same thing. You'll see stuff on Facebook about shows live. And we can pull all that stuff into an app like this and just make kind of an interesting second screen experience. And of course, you can do advertising on it. So, if there's something in the show that people want to buy, you can buy Vanna White's dress or something like that. So you're watching Wheel of Fortune and, wow, that's great, and I want to buy that dress. And you can do it right in this app. That's the kind of thing you can do with these. And then you can also look at recommendations. They can do rewards with this where you get badges, or you answer trivia questions and things like that. There's a lot of stuff going on. You guys should check these out. They're kind of fun. And one more. So the translator. Yeah, I said this. So this is an app that actually exists that our team just released recently. And I'm sure you guys all have Windows phones, right? Hey, all right, there's one. Woo! I have one here too, someplace in my bag. And I can demo this for you. But what this is it's a traveling, it's supposed to help you when you're traveling. So as you go, and it has this capability to do OCR. So it incorporates OCR. So this thing's looking at this sign. It recognizes the text there. It tracks where the text is. So as you hold your phone, if you're a little unsteady, it keeps looking at the same text. And then it translates it to a different language and places it right on top of the text that's there. It supports, I think it supports 6 languages for written translation, including simplified Chinese. It supports 6 or 7 languages for vocal translations. You can talk to it with any words, and it will translate those words for you. And you can type on it. And if you type on it, I think it's like 36 languages to 36 languages. But I can demo this for you guys. But this is a great example of a combination of tracking and OCR, which is a great augmented reality kind of application. So let's pick this apart some. Recognition. What's recognition? There's this concept of figuring out what an image is or what the data is that's coming in and identifying it uniquely among all of the data that you might have loaded in the back end. So you can think about product recognition. This is another product that we sell now that's released for Windows Phone. You can scan a product, just the cover art of the product, and it'll take that image and look in the back end the back end system has, I think, 40 million images of products, and it'll find that image in that 40 million images and then return to you information about the product. All right, so that's recognition. You can have recognition that's audio, you can have recognition that's voice, you can have recognition that's video, et cetera. So we'll take a look at some of these things. This is really an interesting one. So this is the one you couldn't hear, unfortunately, at the beginning. If you can read it, it says translating. So she touched her head, and the voice that was being broadcast was in some strange language, that maybe French or something. And she started hearing it in English. So what's going on here is there's two features, right? There's voice recognition in a different language, which is actually a really hard problem. And then there's translation. So those two things going on at the same time in order to do this kind of thing. Right now, voice reco is pretty, it's out there. You guys have probably seen like Dragon speaking or something. I actually, when I was here in Colorado last year, I broke my thumb. It was a terrible situation. And I went back home, back to Seattle, and I had to get Dragon speaking so that I could actually work because I couldn't type. And it's terrible. I mean, it was really hard. I couldn't use it for anything. I talked to it and it would come up with all these weird words and all this stuff. And so I think if you train it really, really well, then it works fairly well. If you ever use Bing voice recognition, it works okay. Google has voice recognition. It works okay. It doesn't work great. For really limited cases, it works okay. But there's a huge amount of work to be done in voice recognition right now. So that's kind of recognizing voice in a conversational kind of atmosphere is something that just doesn't exist yet. And Siri is maybe the closest thing. And if you try to have a conversation with Siri, it gets confused pretty quickly. So it's kind of the status of that one. This one is this smart art thing, which is image recognition. This is something that's, again, the technology is look at an image and match to something that's stored in the back end storage. The big problem with this is it's a big data problem. The amount of content, in order to recognize all the images that you need. The recognition of 2D images is actually fairly straightforward, and the technology has been around since about 2005. So the functionality to do it exists, but doing it fast and doing it on huge amounts of data is where the challenge is right now. So this kind of exists, and you'll see applications out there that do this sort of thing, like our product Reco does this. Shop Savvy does something like that where it recognizes products. Google Goggles does some art detection. They also do some certain landscapes, but what you'll see is those products do very small numbers of things. They don't do everything. They don't recognize everything. They only recognize a small number of things, and that's the problem. So the general purpose matching is just not there yet. What's this one? This is video recognition. So this is an interesting problem. This one is you're looking at a video stream and trying to recognize the back-end content based on the video that's going by. So actually, this problem is exactly the same problem as this problem, except that the big data problem is even bigger. It's huge, right? The amount of data that you have to fingerprint on a video in order to detect a couple seconds of it and not identify what it is. The back-end data is absolutely gigantic. So there's really not a lot of companies that can do this effectively, that could do it if they were doing it, basically. So there's basically Google and Microsoft are the only two that could reasonably do this, maybe Amazon, that has the ability to store the amount of back-end data that's needed to be stored in order to surface something like this that's real. This is Google's little video thing. This one is another voice reco example. It's again, this is a general kind of voice recognition. So meet me in front of Strand Books. He's speaking that, and it has to be recognized and sent. And I don't know if it needs to be spoken again on the other side, but this is kind of the same like the Dragon speaking thing. It's right around that same level of maturity. And then the last one is the OCR and the tracking. This is actually pretty mature. But the problem with this right now is that it's, I think what I was going to say is it's a known art, but it's really an art. So it's known, but things like recognizing these Chinese characters, there's no shortcut for that. You have to train it with every single character. And then if they're stylized, you have to train it again with every single character. And the cost of that is tremendous. We are doing this now, and I think the last quote I got from my team was that it's $20,000 a language to train it. So if we release 5 more languages, it's $100,000 just to train it, to get the people in to train it and go through it. So it's really a tremendously expensive thing, and again, and something that you're not going to see in the mainstream unless somebody like Microsoft is going to release it because they just have the wherewithal to do it, or Google. But not super technologically challenging. So here's just kind of a quick summary. All the things, the kinds of recognition that are out there. There's voice recognition again, which is, kind of in its infancy. There's audio recognition. There's something else about audio recognition I didn't mention, which is the concept of using audio as a signal. So right now there's audio recognition out there where you can have the device listen to a song, and it's basically the same as the image reco. It fingerprints the song or the video. It fingerprints it, it compares it to a large back-end store, and it returns to you the exact match. There's another concept around audio, which is basically audio as a signal. And this is something that's more associated with contextual information around how you're using your phone or how you're using your device. For example, you might be able to tell if somebody is at a baseball game by the sound of the background, or you might be able to tell that they're in a classroom. And it's possible that you could only tell a baseball game in a classroom, but those two are fairly easy to differentiate. But then you might be able to tell other things like that. So the sound combined with other contextual information can provide a more rich experience for people. And then image recognition is stuff like logos and books. All that stuff is pretty much feasible.
Quick question
Yep.
on the audio.
Yep.
Are you guys doing anything in terms of like context of words as opposed to just the words itself? Like if I'm explaining something to you or posing that question or putting I guess like tone into it, how you are saying it as opposed to what you're saying.
That's a good question. I don't know the answer. I can tell you that there's a team of several hundred people working on voice recognition at Microsoft. It's actually a little bit outside the space of the augmented reality space. We do sound recognition, song recognition, but voice recognition is a very special area. And I wouldn't be surprised if there's work going on in that area, but I'm not sure what the status of it is or where the technology is. So video recognition is things like TV. TV commercials is another thing, being able to recognize commercials and add information. There's tons of advertisers out there that would love to have a second screen experience on all their TV commercials, which basically brings you maybe to purchasing the product even. And then OCR, this is again something that's really pretty well developed, but it's very expensive to do. So let's go on to the next area, tracking and mapping. So let's talk about what that means. Tracking is the ability to understand the location of something within the image viewfinder of the device, right? Whether it's glasses or a phone or a tablet or something else. Being able to know where that thing is and being able to keep track of it even as the device is moved around. That's what tracking means. So that you can then either use that information to augment your, as input to the augmentation, or to be able to augment, place your augmentation on top of that information. It's like in the case of OCR where we put the text on top. Or in the case of a 2D planar target, we can put the augmentation on top, the rendering on top of that. That's tracking. Mapping means to use the image data or potentially other data to create a 3D space into which you can place an augmentation. So imagine I had a device here and it had stereo cameras on it, and I could walk around in this space and it would use the images to create a 3D model in real time. That's kind of the concept of mapping. So you create the map, and then on top of that map you can place augmentations. So let's see. Some cool stuff. Minority Report. So this is a great one. I love this. This is probably the most realistic of all the sci-fi things, I think, because they have these. Everything has a display surface. So this thing, as he walks along, it's talking to him, presumably. I mean, it doesn't really show that, but presumably the lady is facing him all the time. So as he walks along, the lady is facing him and talking to him. Right? In order to do that, they have to track him in the space. And they have to make the display onto the surface in the correct orientation for him, right? So this is science fiction, okay? It really is science fiction, but it's realistic because there's a display surface. A lot of these things don't have a display surface, and I'll show you those in a second. And then there's this other thing like this little stuff that's coming out the side. That's impossible, okay? It's cool, but the only way that can happen is if he has displays on his face. Then you can start to see things. He would be able to see things in 3D that are sticking out. But right now, otherwise, just walking along with nothing on his face, he's not going to see things that are in open space. Let's see. So this is a good one. Drawing the heart in the open space. This one, this would require fingertip tracking, hand tracking. And in order to display it, she would have to have some kind of thing on her, some kind of eyes, you know, some way to display it, like glasses or something like that. So in order to track her fingers, the device would have to do that or something else. And basically that is completely science fiction. There's not even any concept about how to do that right now. The Kinect will track body movement that's big, like your arm or something like that. But with no equipment, you know, this thing is this little see-through card. It's not really very clear how they could possibly do that. There would need to be a way to, with stereo or potentially painting the scene with a LiDAR or something else to be able to track the fingertip. And it's not something that's really feasible right now. So let's see. This one with the thing popping out of the book, this is completely feasible with today's technology. In fact, I would not be surprised if we don't see something like this on the market within the next year. There are several augmented reality libraries that are on the market. Qualcomm makes one called Vuforia. HP makes one called Erasma, and there's another one called Meta.io. They're freely available. You can get them. I don't think they cost anything. Those companies are giving those libraries away in order for people to build applications on top of them because they want people to build the apps and they want to be able to monetize on the apps. So the more apps that get built, the better. So this sort of thing of having an iPhone or an iPad where you can have things appearing out of books and things, I think that's something that we'll see really soon. Okay. This one, I love this one. This is a great one out of the Microsoft thing where she's looking out the window and it says, here's your building, here's your meeting. This says appointment, something like appointment calendar on the top. Your meeting is here, and the building is perfectly outlined, absolutely perfectly outlined, right? But presumably from her position, it's perfectly outlined, and from our position, it's perfectly outlined, right? So okay, so let's just think about what this takes to do this. First of all, you have to know her position with respect to the display, and the position of the building with respect to the display. You have to tie in her calendar. You have to know, let's see, what else? I have this all written down. One question. Pardon me. It's a faux pas to do this. Oh, right. You have to know what the building is. Okay, so you have to know, right. So you have to know where the building is with respect to the glass, where she is with respect to the glass, what's on her calendar. You have to know the address of the thing that's on her calendar. You have to know that this building is at that address, and you have to know about the building. You have to know how tall it is and how wide it is and everything else, right? So when I saw this, I thought, what year is this? This is like out there, completely out there. However, if she was to have display glasses on, the problem would get much easier, right? Much easier because the display of all that information is then known in a known relative coordinate system that she could see it in, right? Then all this information like the geolocation of the building, linking it with her calendar and that sort of stuff is something that we can probably reasonably pull together and display back on those glasses. Running out of time. I'm going to go faster. So. This thing with the car is also pretty feasible now. The concept of the model of the car is something that we can do pretty quickly, and recognizing the car's badge or something like that in an open space is something that we can reasonably reproduce quickly. Let's see, we go on. And this thing is, again, this is this concept of 2D planar tracking, and this is something that exists, and this is the very same technology as this one. The ability to render on top of that. The rendering is not hard at all, and the tracking is basically available in the open space.
I don't see how they could show an image that's doesn't have a straight line between the viewer, projector, and the object. That object is sticking out beyond the rim of the display panel.
This?
No, on top. On that.
Top of that.
Well, this? This? Yes, what? This here. It's ticking up beyond the edge of this. This is a picture of a phone. No, this is just an augmentation that's a display. This thing that's the thing that's actually that's real is this this target, right? So the target is just a 2D planar target. It's sitting on the table, right? So you look at it with the camera. The camera recognizes the target and tracks it. Associated with the target is this rendering, this animation that can be animated, and then it displays it on the phone screen. So it isn't that it's displaying it; it's displaying the 3D thing in the relative coordinate system of the target. The fact that it sticks up above the target is not a big deal, right?
You're looking at a phone.
You're looking through the phone screen. Yeah, all of these. Yeah, this one you're looking through the phone screen too, right? You have to be looking through the phone screen to see these things, or the tablet screen, or your eyes, your glasses. Does that make sense? So components. I'll just go a little bit more quickly. You guys can read this too. But these are all the things. I didn't really talk about all these things, but there's hand tracking, eye tracking, position and attitude mapping, and then this concept of parallel tracking and mapping, which means creating the 3D space and then also tracking and doing things on top of it at the same time. Huh? Why? Whoops. No, I meant to delete that off of all those. No, it's fine. It's not confidential. I stole this deck from the president of OSD because it has these really cool animations in it, and it said that on every slide, and I thought I took it off of all of them, but I didn't. So it's not confidential. It's fine. So services. Services are typically things that are like web-enabled functions or cloud functions that bring all the stuff in. The thing about services that's interesting is that they basically all exist, but bringing them into an augmented reality experience is really hard. It's a lot of work. So, example, Google does a great job with this, with their thing of showing you all the services. It's a few of them, right? So there's like the concept of calendar, your date, time calendar. You can do voice recognition. You might have a social kind of thing where you can chat with your friends, share things with your friends. They have this thing here that they call music, but it's a much bigger genre, right? There's music and books and TV and entertainment in general. There's a task list. There's, of course, search. You have to have search and ads associated with search, of course. And weather and social, and no one uses G+, so it would have to be something other than that, like Facebook or Twitter or something like that. And this is a great starting point. And the funny thing is that most of these things are available on the phone, but this isn't enough. So they actually forgot some stuff, slackers. So there's more. There's stuff like translation, right? So you have to have, this is not in the list, right? So there's translation that you have to have. There's geospatial local stuff. This is their thing that's a map, but it doesn't talk about stuff like where's the bars that are nearby and where's the restaurants and what's along the way. And besides, what about, I'm interested in buying a tent and where's the deal for the tent that's along the way? And then there's the concept of your preferences. So all the things that you've been shopping for and what are you doing and what do you like to do and what's the deal of the day and how is that with respect to my location and do I want to get that deal or not? So all of these things sort of come together. And the last one, of course, is just structured data in general. So the web is filled with structured data we need to be able to offer back to the user in a way that makes sense from the standpoint of what they're seeing. So these services all exist, but they don't exist in a way that we can bring them together and under the augmented reality kind of interface. So this is one of the big challenging areas. I was thinking about this, that Microsoft in like 1990, when I was doing optics, was building word processing, right? They were building word processors. I mean, how basic is that, right? So it's funny, they were building software to do word processing, and they were making a killing at it. They spent a lot of time on it because it didn't exist, right? No, there was no good choice. There was no good, valuable thing that did that. So they built a word processor, and it's the standard. If you look in the last 5 or 6 years, maybe 7, when did smartphones come out? Like iPhone came out around 2006 or 2007, something like that. Since then till now, like the last 5 years, all of these features have been built. Everybody's working on building these features. Google's building them, Microsoft is building them. I can't tell you how many people in Bing Mobile are working on these features. Well, I can, I guess it's probably like around 1,200 people are working to build out all these features, geospatial, you know, voice recognition, chat, weather, date, time, all that stuff, right? So now that's all done, pretty much done. Google's got it, Microsoft's got it, a few other people have it, Amazon, you know. So what's next? Right, so the next thing is combinations of those things. You've got to think about, like I was just saying, well, there's my preferences and there's these deals and I'm in this location, geolocated, and my friend said this was a good thing, and right, so that's what we're going to start to see, that kind of stuff coming together. Right, so services. There's a bunch of services and that's not all of them, and you know, I'm not even going to talk about all of them, right? There's probably thousands of services that we'd want to bring into a real experience that would really augment meaningfully what you would see. Okay, content, duh. Let's forget about services. I don't even have any little pictures for content. But content is all of the stuff that serves the services. The services, right, is like you can have voice recognition and you can have product recognition, but if there's no data behind it, it's not valuable. And this is a huge, huge problem. Like all the logos and all the ads, you want to be able to look at any ad. Can you imagine how much data that is? And it's to be able to recognize any ad in any newspaper anywhere in the world, or any logo anywhere in the world, or any product, be able to converse in any language, not just be able to recognize the language for translation, but to be able to speak the language, to be able to see it and display it, all of that stuff, right? The back end. And then the whole TV thing, I mean, this is like another gazillion bytes of data, right? And then there's this concept of machine learning. So in order for the voice recognition to work, there has to be a tremendous amount of data to train it. So there's all of that data that needs to come in. So content is another gigantic problem. If you watch Google, you'll see that what they do is they're really a content company. Yes, they do search, but they are all about content. All the content that they collect, they own, every single thing. All the map data, all the image data, anything you put up there on their sites, they own all of it. Facebook does the same thing. Anything you put up on Facebook, they own it, because it's all about content. Content is going to be king in like the next couple of years. It's all about content. Whoever controls the content is going to control all the money in the web. That's where it's going. It's just the way it is. And then, oh yeah, there's rendering, right? So there's that part of where you display it back to the user, which is, I'm not even going to talk about it because it's something that is kind of mundane. It's been around for years, and you can get open libraries for it and all that stuff. So let's roll it all up. How do we roll it all up? If you think about that, it's actually, what's going on is that the desktop search stuff is going away. Search is going away. And I can tell you, Google is worried about this. They are freaking scared to death. I won't say the other word I was thinking. But they're definitely scared. They're really concerned that the whole concept of search, which is then the whole advertising around it, is going away. And what we're seeing with smartphones, right, is we're seeing this appification of the web. I don't know if you guys have heard that term. That's kind of a Microsoft term. Microsoft makes up all these words. Anyway, appification of the web, where people are no longer searching, but instead they use apps on their phones. So you don't search for an ice cream parlor, you use the ice cream parlor app to find the ice cream parlor that's near you. You don't search for Starbucks on Google or Bing, you use the Starbucks app. So you have all these apps on your phone. And now, I don't know about you guys, but my phone has I have an iPhone, I have a Windows phone too. But I have five screens of apps. So it's hard to find the right app. It's so confusing, right? So basically, things are shifting away from this generalized search to this appified web. And then what's going to happen after that is that it's going to shift more away to this more natural user interface. And you see that with Siri. You know, people are talking to their phones now. So you see the natural user interface with the input, but you don't see yet is the natural user interface with the return display to the user. So it's going to be both ways. So what this is going to happen is the roll-up is going to be this combination of natural interfaces and structured content. It's going to feed into this thing that's going to change the face of the way we we interact with our devices. And I'll just step on through the rest of these. So it's basically, on the natural side, there's voice, there's what you see, there's this ability to track, and then this ability to render the data back to you. And the structured content on the other side is all the stuff that's in the web, like restaurant listings and reviews and, you know, the whole web thing, then all the whole social thing, the concept of geospatial, and then rolling in entertainment. All this stuff is going to come together in a natural user interface kind of thing. Maybe Google will get there first. Maybe Microsoft will get there first. Maybe somebody else will get there first. So big challenges. So the really big challenges is on the data side. It's sad because you guys are like, oh, the technology is so cool. It's the technology. Actually, that's not the challenge, because you know why? There's all these super smart people working on technology. The data is really a hard problem. Getting all the data together in the same place, all the content, all the services, paying attention to what users want, the way they think, the way they, what their preferences are, what the context is of where the phones are and where the devices are, and having that context feed automatically into these things. So that the thing becomes an assistant that sort of is so personalized that it's only yours, right? We have this concept that the device becomes a personal assistant, so much so that no one else would even want it. No one would steal it because it's yours. It's useless to somebody else, right? It's got all the information in it that's just yours. And to bring that all together into a comprehensive service and do it in a way that isn't creepy, right? This is really important because there's a lot of private information here. So what everyone's thinking and what they're doing and the way what their preferences are, and you know, I talk about being able to see somebody's face and associate, you know, your name and where you went to school and how old you are, and all that. It's a lot of personal information, right? And it's on my device. I can see that about you. That's creepy, right? And we don't want it to be creepy, because if it's creepy, nobody will buy it. It'll scare everybody, and the Congress will say it's illegal, and that'll be the end of it. So this is a big challenge too, huge challenge, in a way to bring it to market in a way that doesn't freak everybody out. So that's basically all I have. And I will close by saying we're hiring. We're actually expanding our team in the augmented reality space, both in the image reco space, which includes OCR, image recognition, and in the audio reco space. So if there's interest, come and see me. Questions?
So I was actually wondering if there's limitations that you're in all that you want to do because of not having solutions to more generic object recognition or activity recognition that would sort of open up other doors if we had answers to those computer vision problems.
Right. That's true. It's definitely limited by that. And I should have talked about that. In fact, I remember that as one of the notes I made on one of my slides, and I didn't mention it. But there's this concept of object recognition, which is sort of the general purpose thing. And I talk about image recognition. So I'll say, first off, there is a, you guys probably understand the difference, but there is a lot of fundamental misunderstanding about what the difference is between the types of recognition. Image recognition is actually much simpler than object recognition. It means I have an image of a cup, and I have 10,000 images of a cup stored in my library, and I can tell you which image of a cup this one is out of that 10,000. But I can't tell you that it's a cup. I don't know what the hell it is. Okay? So figuring out that that thing is a cup, that is totally research right now. There's that I'm aware of, not anything even close to productization that would be able to crack that problem in the general sense. There might be something specific that, you know, for example, cup recognition specifically. There might be something like that, but general purpose object recognition is just not something that's around. Did that answer your question, or?
Right. So I mean, I was thinking more in terms of you talking about being able to service the engine in your car, and it seems like if there's someone working alongside the augmented reality, you'd also have to be able to identify what their actions are translating into, so you can provide the right information. So it seems like you'd be able to do only half the task at this point with being, you know, projecting the information you do have about the specific engine, but to be able to work along the user, you need to be able to identify what their actions translate to, where they're looking, and what the object they're looking at translates to.
Right. You have to have really good images of the car. But yeah, I think you can do it if you have really good images of the car. and really good images of the car in all states of disrepair. Right? As you take it apart, you have really good images. But you're right. I guess to the extent that the guy takes out the spark plugs and leaves them on top of the engine so it changes the look of it, that would probably impact it. That's a good point. Right. Yeah. Let's hope that they don't start. Yeah.
Okay. My first question is, I just want to make sure you don't have an electric car, do you?
I do not.
Okay. I just want to make sure that wasn't why it seemed foreign when you opened up. But,
it is a foreign car.
Okay. I was wondering, how do you mitigate the risk of when you're doing translation to make sure that certain things aren't mistranslated, especially if you're dealing with some sort of medication or something like
yeah,
that?
we.
They get bad, seasick pills, and they take them wrong.
That's a good point. I think we basically have some kind of a disclaimer associated with it right now. I mean, the app for translation is really marketed to be a travel application.
Okay.
So if you're using it for medication, you're taking your chances. And the fact is, it actually translates things sometimes very sillily. And it's silly, and it makes sense funny, and it's obvious. It isn't perfect. And I hope nobody uses it in a way that they expect it to be perfect. And that's going to be the case with this stuff for a long time, I think. Did you have another one?
No.
Oh, the electric car was the first one.
That was
Gotcha.
So there's the grand vision in those videos, and then there's the day.
Yeah.
You want to speculate, at least in the first couple steps, how from today we might get towards that grand vision. We're not going to have the hardware and the apps and the data and all those things on that last slide instantaneously. What do you see coming in the short term that might be that?
I think Google's on the right path with the glasses. I think that the heads up or the on-your-face display is if people really want this, and it actually isn't that clear that people really want this, but if people really want this ability to draw things in space and have things flying around other people, there was a scene in Minority Report that I didn't stop it at, but there's a scene where the stuff is coming out and it's going around one of the people in his view, right? Which is impossible unless you have a display on your face. So if people want that, then I think that's going to be the thing that comes next. And then it'll be a matter of integrating stuff that's like on your phone now. The first things you'll see is a device that goes on your face that has all the same functions as this device. And maybe with this device in your pocket that it talks to. And then over time, it'll get better and better and better. That's what like the phones have.
Is Microsoft doing any work in first-person sensing? So in other words, more like wearable instrumentation. It seems to be very focused on physical spectrum right now. So something different than just I see this, the camera sees it, but actually looking at things in infrared.
Probably, they probably are. There's not that I know of, but that doesn't mean they aren't. There's. So you haven't first. No, I mean, I know what you mean.
Okay.
I know what you mean. I just don't know if there's any work in that space. I mean, it's a cool concept, and I can see us collecting contextual signals from sensors like that. But, Microsoft is pretty focused on the phone and the Xbox and the tablet for some reason. But there's MSR. I would not be surprised if stuff's going on over there. There's a lot of people at Microsoft. I don't talk to all of them. Yeah.
Is anybody working on some kind of like a biosensing type thing, like maybe a device that tells you like blood sugar is low or you're dehydrated or something? Or is that like a really hard problem or not profitable? It seems like that could be useful.
Probably. Again, this is an MSR question. I'm sure there's somebody in there doing it. You know what I saw recently at CES though? This is not Microsoft, but I saw a device that would. What would it do? It would extract. Oh, it was a bracelet for Alzheimer's patients, and it would detect elevated stress, and it was powered by the person. So it touched the body, and it would extract power by what's that called? You told me about it. Where it harvests the energy from the person, so it doesn't actually have a battery in it. And then if the guy got too far away from wherever they, like if they get lost and they went away someplace, it would alarm and it would send a message back to whoever needed to find out. So that kind of stuff is happening, but I'm not exactly sure about the biometric. That's biometric, but it's not like what you were talking about. But